No clue. Not a clue. Not a singular clue as to what's going on. Okay, I'm getting somewhere. I don't understand it, but I'm getting somewhere. Hello guys, today we're going to be working on trying to get our LSTM, at least feed forward portion of LSTM working in Excel. I won't lie, I actually spent a lot of time editing yesterday's vlog. There was so much confusion, so much confusion that I actually had to, at least formulate a story that kind of makes sense because it was very, very messy yesterday. Like, I just hope you guys enjoy, at least are able to make sense of the vlog that I put out. But what that means is that I didn't have time to take a look at other resources for LSTM. So I will do that for about 5 minutes, and then we'll code for maybe 30, 45 minutes, and that'll be that. When I say code, I mean just encode it in Excel. Just post on Reddit. See if there's anyone who can help me out. My only issue with Reddit is, like, the bot thinks, like, they think I'm a bot on Reddit, so half my posts get blocked. I should really read through this paper when I get the chance. This looks like a juicy paper. What the hell is this? What the heck is this? Oh, I think this is just like it's a useless. The last thing I'll do is I'll just take a look at Wikipedia and see if Wikipedia has pseudocode that I can copy. I have to go to the bathroom. Okay, so Wikipedia is just filled with math. It doesn't really have any pseudocode that I was hoping they would have. Just going through this paper and seeing if this paper has any pseudocode that I can use as reference. I understand LSTMs from a theoretical standpoint. I just need to, like, there's a lot that I still need to go through before I actually understand it from a practical standpoint. And in order to understand it from a practical standpoint, I want to go through some code, or at least use a working implementation of code as my reference as I build it out in Excel. That's all I've been looking for. Okay, so these guys don't have pseudocode. Let's back to this guy. Oh my god, okay, let's do this all over again. Okay, so actually this time what I'll do is I will, once again, I have about 15 minutes, so let's just go line by line in this code, and we will see what to do. So let me come all the way down here, because down here is kind of where it starts. Now I merely load some sequential data, in this case a research paper of mine. Try to predict the next word of each given the word. Look, I don't know. Like, obviously all due respect to whoever wrote this, but I'm just having, and maybe they weren't expecting someone like me to use this as reference for building an LSTM from scratch. So, but I'm just having a hard time going through this. That's the definition. Okay, so this is just taking text and he's just tokenizing the text, and then his output size is the length of the text. Okay, so then he is getting unique words. Okay, and then he gets unique words and data size. The same thing though. Why would you need two? Let me continue going on. I have no clue what this does. It's like this is making an identity matrix, I think. But then what does this do? No clue. No clue. Not a clue. Not a singular clue as to what's going on. So let me build out this part. So I don't need any arrays, but let me at least just build out and just see what he's talking about for these gates. Yeah, let me just build these out. I only have like 10 minutes or so it's not necessarily going to be the best. I don't even know what to call that. What should I call those? Gates? I'm going to call them R and N gates. So before the LSTM portion, I'm going to call these R and N gates. Our forget gate will be just zeros of length recurrences plus 1, so number of time steps plus 1. The first one would be kind of the hidden, or like t minus 1 that we have, and then output. So that shouldn't be too difficult to implement. What's it called again? Oh yeah, it's called forget gate. Okay, then we have our input gate. It's the same thing. We have our cell state, which is the same thing. We have our output gate. They're all the exact same thing. Okay, I don't know what the heck they're for, but we're just adding them there for now, I think. Okay, now we jump into LSTM, or the LSTM portion. So now the LSTM portion, self.x for an LSTM. is, okay, so let's set that up. So an array of zeros of size, or a vector of zeros of size input plus output. So in our case, that'd be 8. They define this, but I don't really think they use it unless I'm mistaken. Self.y. Okay, let's implement that. I'm going to implement that right below, right below this. Okay, so then I need another cell state variable. Sure. Why not? Why the hell not? So you know what I'll do is I'll actually just move this. Move that there. LSTM X and LSTM Y. Just move them here. And then we have cell state. Again, this is very messy, but organization isn't what I'm optimizing for right now. Okay, so cell state is also a vector, and the vector is of size output. So essentially just this. Actually, you know what? Just copy this whole thing. Okay, now our forget gate. So yeah, we've already implemented all these yesterday. Of size output and input. Input plus output. So we've already done all that. Forget gate gradient, input gate gradient. I'll deal with those when I get there. I just want to implement feed forward first before we do anything, or before we get too ahead of ourselves. So all we've really done is we've just, where is it? We've just implemented this line of code. And so now we're moving through. So RNN forward prop, nothing gets passed into it. So that's good to know. So LSTM.x is equal to MP HStack. I'm pretty sure HStack is just horizontal stack. Self.ha minus, what's self.ha? Oh, hold up. Why is the array for storing hidden states recurrences plus 1? Yeah, what the heck? Okay, I'm getting somewhere. I don't understand it, but I'm getting somewhere. So our new LSTM.x in the first time step, LSTM.x is now equal to, when you do an H stack, it stacks the first, let me just look it up. Okay, yeah. So the first, when you do an H stack, the first variable, so in this case, A, where's my pen? A gets added on top of B, that's it. Okay, so then what this guy's saying, he does an H stack of self HA minus 1. So self HA is the hidden state, array for storing hidden states. Recurrences, but why are you doing recurrences plus 1? That's what I want to know. Whatever. Where am I? Okay. And then self.x. Okay. So what I will do is I will assume that we have, because number of recurrences is, oh my god, I'm getting pissed. Okay, hold up. How many recurrences do we have? Okay, so we have 1, 2, 3, we have 4 recurrences because there's 4 time steps for us. So actually, I even did these wrong. Hold up. Man, this makes less sense. Okay, so unique words, number of unique words you have in your thing. Output, forget output. Output size is the number of total words you have in your data set. Okay, so then what you do is you take unique words, you pass it as input and output, right? Number of unique words. How the what? Hold up. That makes even less sense. Why are you passing number of unique words as your output? Your output is something different. I don't think your input size and output size should be the same. Okay, but that's not even what's confusing me, because what's confusing me is, okay, let's take a look at HA. So HA, let me just draw it out and make sure I'm not going crazy. So going to this, HA is a matrix that has size of recurrences. So let's say, I don't know, let's say there are 5 words in sentence. Actually, no, let's use our example. So our example, we have hello. We have an output size. Sure, let's use our example. Let's go through this. Let's go through his line of code with our example, just very, very quickly, because I have to bounce. So our variables would be return data. No clue what the hell that is. I'm not even bothering. Unique words. I'm going to say unique letters. So we have, in ours, we have 4 unique letters. And then we have output going to, okay, so unique letters, output is equal to just the word hello. That's really all it is. No point in. Well, actually, so what he's done is he has made it a matrix like this. So HELO, and then he has like time step 1, 2, 3, 4. And so, you have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. HELLO. Sorry, it's 5 time steps. Hold up. Time step 4 has this as a 1. Sorry, it's going vertically. I was going horizontally, and I was wrong. And time step 5 has everything as zeros except for O. Actually, no, there is no time step 1 really even. Because time step 1, you're feeding. So this is like -1 really. This is okay. ELLO. Number of unique letters. Then I have my output itself. Then I have my output size. My output size is equal to 1, 2, 3, 4, 5. 5. I have 5 letters in my total array. You know what? Let me play around with this because I have to go to work. Let me play around with this, see what it is I can come up with. I'll run our example through his code just to kind of stress test it. If that still doesn't make sense to me, what I'll do is I'll actually, because this is Python, so what I'll do is I'll just open up a notebook, go through his code line by line just to fully understand what's going on underneath the hood. And once I understand that, then I can hopefully encode it in Excel just to solidify the information. And then once that's in Excel, we'll then move on to our code. Oh, this is a long journey.